How to use your item box steel tab. When we go into our architectural bin and select a beam, here in this tutorial we're going to grab one from the main wide flange shape. The second we grab the steel beam, PractiCAD is going to depress the steel tab inside of our item box. Here we're going to have a variety of options we need to answer before we place the steel down, and we're going to go over them one at a time in the following tutorials. How to change your parameters inside the steel tab. The first thing you must do when you go to grab a steel beam is make sure you have the proper parameters. PractiCAD allows you to choose all the parameters and adjust them on the fly as you're drawing. However, with steel, most of the time we are grabbing it from a preset catalog. We're going to come over to the architectural bin and we're going to grab a wide flange shape. And you can see by the little blue icon that this is a catalog entity. So in other words, when we click on the icon, you're going to get a catalog window with a drop-down menu, and we're going to choose the YW by 22. PractiCAD comes with all this information already inputted for you. We're now going to hit place. Once we hit place, you can see all the properties are now lit up inside the steel tab in your item box. To demonstrate what each of these do, we're going to click on the drawing twice, and then we're going to come over to the item box. Here you can see we can adjust any parameter we want by simply clicking on it and then either giving it a value or rolling with the wheel mouse. Here you can see that the depth can be changed, flange width, flange thickness, web thickness, length, and then we have orientation. And orientation basically means rotation. This can be done from outside this box as well, and there are separate tutorials on placing down steel. We also have the last properties of location, so we could give this room 1, and we also have special instruction properties. Once we've selected all the proper parameters, we can now place the steel on the drawing. The second part in the steel tab is using your hold points. You will know that when you go to grab a steel beam out of the PractiCAD catalog and go to place it, PractiCAD will allow us to choose the hold point in which we're going to place this beam down by. It works exactly like fittings. Notice currently that the crosshair is in the dead center of this beam. That is because we currently have the hold points at Z center and X center. If we would like to change the hold point on the Z axis to top or bottom, just click on the one you'd like, and now you will notice that we are holding this by the bottom center. We can also click on it and now hold it by the top center. Same thing with the x-axis. If we'd like to switch it so that we're holding the top right portion of this beam, we just change the x-axis button in the combo box, and now we're holding it by the top right corner. Once we've chosen the proper hold points, we can now place the beam on the drawing. Part 3 of the steel tab is utilizing the slope features inside the item box. In this tutorial, we're going to show you the two different methods to utilize the slope parameters underneath the steel tab inside the item box. However, there are other tutorials showing you how to place down steel in a variety of different methods. The slope parameters represent the Y over the X or the rise over the run. For example, in this tutorial, we're going to place down a beam, and we're going to say that the Y or rise will be 1 inch for every 12 inches on the X. Note that I have my format and precision set to decimal, so I'm typing in inches. If you have your format and precision set to feet and inches, you'll be typing in feet and inches. Here we're going to say we're going to have a rise of 1 or Y of 1 for every 12 inches on the X. And to demonstrate that, we're going to go into the architectural bin. We're going to grab a wide flange shape from our catalog. We're going to press place. And now what we're going to do is say the bottom of this beam is going to be at 10 foot and hit enter. Now we're going to click on the drawing one time, and I'm going to hold it in this direction. I'm going to put the polar on to make it easy. And we're going to hold it in this direction and type in 120 inches in the command line and hit enter, or 10 foot. And we're doing that just so we have an even number of feet to represent the rise and run. We're going to rotate this as 0. And here you can see that we've got the bottom to start at 10 foot 0 inches. And then the end of it is at 10 foot 10 inches. So what we've done is we've gone up 10 inches. And that would make sense because the run is actually 10 feet long. The length of the beam is 10 foot, and we wanted to go up 1 inch on the Y for every foot on the X. And we went 10 foot on the X. So here we've got bottom 10 foot on one side and bottom 10 foot 10 inches on another. So that is one way of using rise and run. There's another way of utilizing the slope parameters, and that's to just give a rise parameter. Imagine we'd like to place down a steel beam, and we would like this beam to be 2 foot difference between the start of the beam and from the end of the beam. We don't know the rise and the run. We just know that the beginning of the beam is supposed to be at 10 foot, and the end of the beam, however long it may be, should be at 12 foot. So we want there to be a rise of 2 foot. What we can do is we can type in the y-axis here, 24 inches, to represent 2 foot. And then we give the x or run parameter a 0. And here what we're going to do is type in 0. So all we do is type in 24 inches or 2 foot. Now what will happen is if we go to grab the exact same wide flange shape and place it on the drawing, we're going to now click on one point and then go across the drawing and click on another point right here and place it. When we do that, you'll notice that the end of the beam is at 12 foot and the beginning of the beam is at 10 foot. So we've gone up exactly 2 foot, or the rise was 2 foot, and that just happens to be calculated based on the length of the beam. In other words, it doesn't make a difference the length of the beam. I just know that when I click between 2 points, if I measure the rise in height, it will be exactly whatever we've typed in here. So another option is to put in a parameter for the Y or rise and a 0 for the X value. And those are the two ways of utilizing slope parameters inside your steel tab item box. Part 4 of the steel tab is working with the Save as Default key. The Save as Default key is the same for steel tab, fitting tab, and every other item in the item box that has a Save as Default button. So this tutorial is going to cover them all. Save as Default, when depressed, simply saves the last parameters of any given entity, so the next time you use it, the parameters are whatever you last inputted. For example, we're going to go into the architectural bin and we're going to grab this wide flange shape. Take notice that there is no red, blue, or green icon in the bottom left of this entity. I'm going to click on it and then go over to the steel tab parameter box, and notice Save as Default is lit. This will allow us to change the parameters to whatever we want. In this tutorial, we're going to choose 12 and 12, and then click on the Save as Default key. Now, if I were to let go of this item and then grab it again out of the same bin, you'll notice that PractiCAD has saved those parameters as a default. Now, one very important thing to mention is this will only work with original PractiCAD entities, and they can always be recognized because there is no red, blue, or green icon in the bottom left corner of each entity. Notice here we have a red icon, here we have a blue icon. And if I choose this wide flange shape catalog and then hit place to select an item out of that catalog, you'll notice the Save as Default button cannot be pressed here. If I want to change the actual catalog entity, I must go into the library icon and change it there, and there are separate tutorials on that section. Part 5 of using the steel tab is working with your snap to hold points. Notice here under the steel tab in the item box, we've got snap to, and we've got Z set as center and X set as center. This was added to the system to make it easy for us to tag and dimension from any part of a steel beam. For example, if we zoom in very closely to the steel beam we provide, you will notice that there is no line at the dead center of this particular beam. However, often draftsmen want to be able to dimension from the center of steel. So PractiCAD has added invisible lines that run through the top center, center, and bottom center of each steel beam. We can also dimension or tag from the sides just by changing the snap to hold points. For example, in this tutorial, what we're going to do is we're going to grab a linear dimension tool, and there are separate tutorials on dimensioning. We're going to grab the linear dimension tool, and notice now that I have the nearest snap lit up and it's on the dead center of the beam. So when I move my crosshairs over, you can see that AutoCAD is the nearest node lit up. Very important when you do this that you have your object snap settings turned on. You will notice in the bottom of my screen I have object snap turned on. If you do not have it turned on, you will not see the node. Once it's turned on, we can choose where we'd like to snap from. So here you can see that we're actually getting a node right on the center. Even if we move our cursor here, it's still holding the center. However, if I switch the X to the right center, you can see that PractiCAD now allows me to dimension from the right. Same thing would be for the left. We can also adjust the Z-axis for the bottom, top, and center by switching it in the combo box. So we're going to put 2 dimensions on the drawing. First, we're going to dimension from the right side by clicking here. Then we're going to come over to our fitting, and we're going to put in 1 dimension line. Then we're going to shift it, so we're going to dimension from the center of steel by changing the Snap to combo box here. We're going to choose our linear dimension line again. And now what we're going to do is we're just going to click and then click on the duct. And we don't need to zoom into the beam because once we've got it set at center, we know that that line will be perfectly in the center of the beam. So Snap to makes it very easy to work with dimension lines and tags utilizing our steel. This is also going to become very important when we get into how to use the point elevation tool, and there are separate tutorials on that.